Okay, so hi guys, welcome. Like I mentioned, if you haven't already introduced yourself, please take a moment to put your name, your program's name, and your role within that program within the chat box so we can see who's here. So good afternoon, and thank you for joining us for the third session of the GED Virtual Training Institute. For those of you who joined us for the first two sessions, thank you for having us again, or for joining us again today. And welcome to anyone who is joining us for the first time. My name is Gina Davis. I am the Professional Development Specialist with the DLLR Maryland team. And I'm going to briefly give an overview of the Zoom platform before we get started. So if you can click the next slide for me, that'd be great. Okay, so as you may notice this time, everyone has started muted. And when we have the breakout room sessions, I will unmute everyone to give you talking privileges, and we'll troubleshoot that as it comes. But if you're having any tech issues, please feel free to message me directly. As I mentioned, all of our webinars are being recorded so that they can be available at a later date. And that is pretty much it. If you have any problems, you know how to reach me. But I'm going to turn the presentation over to Cathleen O'Neal, who did a wonderful job last week, and we look forward to seeing for today in Science and Social Studies.
Great. Thanks, Gina. So good afternoon, everyone. I'm Cathleen O'Neal. I'm the Assistant Director and the Adult Basic Education Specialist for Strong City, Baltimore's Adult Learning Center. So welcome to everyone today. I'm so glad you've chosen to spend 90 minutes with us talking about social studies and science. If you joined us last week, I hope you got the sense that I love math, but I think I love social studies and science even more. And I've had the pleasure of teaching this content and really using it to teach language arts and math skills for the past couple of years. So I'm really excited to share what I know with you today, but more importantly, I hope you will share your knowledge. We all can work better when we pool what we know. So please feel free, as we're going through, if you have a comment or a tip or something to add, please put that in the chat box so that everyone can benefit from that. So I'm going to start off today just kind of giving you a sense of what I hope you'll be able to know after we go through today's session. So the main thing is that when I share with you and hopefully also learn from you some strategies for building a culture of inquiry in your classroom. So basically, building from learners' curiosity and building a culture where you're constantly questioning things. We're also going to learn how to apply strategies for incorporating math and reading skills into social studies and science instruction. And I'm going to share a couple of brief resources that you can use for lesson plans. So, cross-curricular connections, you say? Why, yes. Okay, so forgive my goofiness here, but I think I always get really excited about ways that content can cross different sections of the test because as I'm sure you all have experienced, we have really limited time with our students. So the more time we can use teaching skills that go across content areas, the better. So that's really what I hope you get out of today. It's just a lot of strategies that you can use, of course, in social studies and science, but that you can also use to teach math and reading skills as well. All right, so kind of a brief agenda for what we're going to do today. We're going to quickly look at some, just a quick numbers graph of the social studies and science outcomes in Maryland specifically. Like I said, we're going to talk about how you can build a culture of inquiry. We're going to do kind of a deep look at the scientific method and experiments, exclamation point. That should be fun, I hope. We're going to look at some strategies to build visual literacy, and we're also going to look at close reading with primary sources. All right, so to start off today, I just want to share with you what the Maryland outcomes are. And these are courtesy of Adora Beard, who facilitated our first session. So this might look familiar to you if you were participating then. But the good news with social studies and science is that we have really good outcomes on these portions of the test in Maryland. So you can see that 88% of students pass science and a similarly high percentage in social studies, 84. And what's even more exciting is that the students who are not passing those scores aren't many points off. So those are students who, if they took the GED Ready exam, they'd be in that too close to call range. So as I mentioned last week with our math training, and Adora mentioned the week previously, it's really great when you see outcomes like this because you know that implementing just a few key instructional strategies can really make a big difference for students. So that's really what we're going to kind of dive deeply in today. But it's really positive to see that many of our students are successful on these portions of the exam. I think much of that goes, thanks for that goes to our instructors who are doing a really awesome job preparing students. All right, so we're going to start off with a brief poll here. All right, so this is going to ask you basically what skills in science do your students already possess? And with this, you can choose as many that apply. All right, so we'll take about 15 more seconds for people to vote. All right, I'm going to go ahead and share our results now. Okay, so make sure y'all can see these. Oops. Let's see. All right, hopefully you all are able to see these. So we had 20% say students can create a well-reasoned hypothesis. 60% say they can identify variables and experiment, which is really great. Only 13% say they can apply formulas from scientific theories. I think I definitely have experienced that with my students. That's often the most challenging thing. And I'm also excited to see here that 60% said your students can display scientific information and findings in charts and graphs. So that's really great. We have a good basis to work from. And a big portion of what we'll talk about today is how you can integrate math into your science instruction and vice versa. So, seeing that there's a need to work on these formulas is exciting to me. All right. All right, so I'm going to start off, obviously we're going to talk about science first here, just to kind of share some of the resources that are available for GED testing service. So basically, this is a slide that's showing you, sort of what to teach with science. So in order to ensure that students are successful on the exam. So there are some focusing themes for science, and we'll delve into those a little more deeply on the next slide. And then also science practices. So basically, if you can have students apply those science skills with science content, you're going to ensure that they're successful on the exam. All right, now one main challenge I know, and I've definitely experienced this personally as an instructor, is there's so much to teach, how do you choose? So GED Testing Service has put together a really helpful guide of the content that is sort of most covered on the exam. So, and they've kind of developed it into two focusing themes. So the first is human health and living systems, and that includes things, down from the cellular level to evolution, chemical properties, and then interactions amongst living things. And the second focusing theme is energy and related systems. So relationships between, things like the food that an animal eats and the energy that they intake, and, kind of food chain stuff, energy flows and ecological networks, transformation and flow of energy, work, motion, and forces, structure of the cosmos, things like that. So, if you're wondering what to teach, how can I design my units, this is a really great guide for that. All right, so, and I believe Gina will share the PowerPoint with y'all after the presentation. So this is a really good slide to kind of bookmark, when you're planning things and you're wondering what direction to take, this is a good one to reference. Okay, so here, this is another slide from GED Testing Service. So these are basically just the science practices. So we spoke last week about sort of the mathematical practices. These are the ones for science. So I'm going to be quiet for about 15 seconds so you can have some time to take in the content on this slide, and then I'll tell you a little bit more about it. Okay, so I always like to give a little time for people to read, because I know sometimes when I'm viewing webinars or trainings, I'm like, I want to see it all and I don't have time. But what I really want to focus your attention on is really that circle in the center, which is about arguing and critiquing. So, if you've had the opportunity to teach science in your class, I think you've likely observed that most of the real learning for students occurs when they are deeply engaged with content, when they have the opportunity to formulate hypotheses or theories, and really argue those with each other. So really what you want to do in your science classroom is as much real science as you can do, the better. So the much experimentation you can do, the better. And I know sometimes as adult educators that can be scary, or we don't want to put the prep in, but I'm going to show you some experiments today that really don't require much from you. There are things that you can do that you probably just have laying around already, or just simple things from your kitchen that you can bring in to really drive scientific inquiry. Okay, so another brief slide here from GED Testing Service. We have spoken throughout the GED Institute about these high impact indicators. So these are the skills that if you can teach these to students, you're gonna have a really great impact on their outcomes on the GED exam. Because these are skills that not only are impactful in one content area, but reach across content areas. So we have things like identifying or refining hypotheses for scientific investigations. Evaluating whether a conclusion or theory is supported or challenged by particular data or evidence. That's one that really jumps out at me as something that's also majorly assessed on the RLA exam, particularly through the writing portion, where students have to assess which argument is best supported. So that's a really major place where you have a cross-curricular connection, where you can do this in science, but also make a big impact in the student's success on the reasoning through language arts exam as well. And another big one that I love from these is applying formulas from scientific theories. I can say I love it, but my students certainly don't, but it's something that has a really big impact for them. Especially there's a great connection there with algebra and just sort of that idea of cracking code of math. So that, if you put a lot of effort in there and a lot of practice with students, that's going to have a great impact for them. So this is another great slide to kind of bookmark. If you're wondering, what do I teach out of all these science skills? These are kind of the key things. All right, so big thing I wanted to talk about today is building a culture of inquiry with your students. So I would love if you, have suggestions of what that means. I'm going to ask you that in a couple of slides, but you can start thinking about how you do this in your own classroom. But first, I want to just sort of share with you what we mean by this when we say a culture of inquiry. So inquiry is an approach to learning that involves the process of exploring the natural or material world, and that has learners asking questions, making discoveries, and testing theories and discoveries in the search for new understanding. Some of this is blacked out for me, I'm sorry. Inquiry as it relates to science education should mirror as closely as possible the enterprise of doing real science. So I want to really draw your attention to that last part there. Our best science education is going to occur when students are doing real science in the classroom, because it gives them the opportunity to really go through the scientific method. And I think, for many of us, we've observed with our students, if you tell them, there's a certain amount of retention. If you show them, that retention increases, but if you involve them, their ability to retain that information is much, much greater. All right, so let me get myself situated here. All right, so I'd love now if you can take a moment or two to consider how you build a culture of inquiry in your classroom. And if you wouldn't mind sharing those ideas in the chat box. I'm going to give you all a few tips and pointers in a minute, but I'd really love to hear what you have to say. So Jamie, I'm so glad you're the first comment here. She has said, letting the classroom be a safe space is the beginning of this. Absolutely. So many of our students have the experience where, they haven't been an active participant in class, or their ideas haven't really been valued. So just establishing from the beginning that your classroom is a place where it's okay to ask questions. It's okay to challenge each other, and really it's okay to challenge the teacher too. I know a lot of us, myself included, I don't have a science background. I'm kind of learning as my students learn, or learning the night before. So it's really okay for students to question the teacher. There's one teacher in our program who, anytime a student would catch a mistake, she would give them a pencil. And I love that, because she really was encouraging, I'm not the authority in this room, we all share that together. Okay, so Gina has said, foster conversation by giving positive feedback to anything asked. Yes. Oh, they're coming in faster now than I can read them. Okay. Diana said, always ask what questions the students have about the content, i.e. what piques their interest and what more do they want to know. Great. Cheryl has shared, ask students how they know or can show that something is true or not true. Definitely. Pamela suggested presenting a situation, asking them to solve. Sherry has said, starting with a safe learning place and as many hands-on activities as possible. Oh, and also real-life connections. Great. All right, and Cynthia has shared, I try to relate the experiment to something that is relevant to their everyday life. I encourage them to ask questions and to give feedback. Great. Yeah, so really, if you can start your classroom with a question, that's ideal. And it's even better if you can have the question come from the learners. Now, I know from personal experience, it's sometimes hard to get them to ask questions in the beginning. You kind of have to get them going on it, and it might be, you know, where you have to model some things in the beginning. But maybe you start with one question you have, and you know, you do some inquiry around that, and then that's just going to give them the permission to ask questions from there. And I love here that Jamie has shared monitoring instructors' tendency to correct in a way that encourages continued curiosity in students. Yes. I'm sure we've all had that experience where, you know, you ask a question, you get a really kind of off the wall answer, you know, and sometimes our tendency is to be like, no, that's not right, you know, kind of just shut it down. And I think sometimes we have the tendency to do that because we fear that it's going to confuse other students. I really want to encourage you to let that go. You know, it's okay for your students to be confused for a bit. You know, sometimes that's where the real learning happens. And, you know, some of our greatest discoveries have occurred because someone asked an oddball question or had a weird, you know, what looked at first glance as a weird theory. So you want to just, you know, respond to every question positively and be honest if you don't know the answer. All right, there's a few other key things I want to share with you about building a culture of inquiry. And one is to really celebrate mistakes. So, you know, a lot of times if you're going to do experiments in class, you don't exactly know what's going to happen. And I've definitely had the experience where, you know, you're testing a scientific law, you really know what the outcome should be, but then you do an experiment that sort of proves the opposite. You know, or somebody does something out of order, or you end up spilling, you know, vinegar all over the table. Whatever happens, you want to celebrate it. And, you know, aside from those sort of procedural mistakes, there can be mistakes in thinking, and that's okay. You really want to, you know, encourage those because that's how we learn. But that is a hard thing sometimes for our students to embrace because, you know, they've had an educational experience where it wasn't okay for them to make mistakes. And as a result, you know, they withdrew or retreated. So it can take a little bit of time to get them, you know, to accept this. But once you do, you can really have some great learning outcomes. All right. The other thing really want to encourage you to do is be a geek and nerd out. So the little nerd glasses emoji, I've found that that's my most frequently used one. I didn't even know it was for a nerd, and then one of my friends was like, why do you always use the nerd emoji? But it's something you should embrace. We talked a lot last week about, you know, getting excited about math and having fun with math. It's sort of the same thing with social studies and science. If you're excited about what you're teaching, it's going to be contagious. And I think doing experiments and having a culture of inquiry in your classroom, it's so exciting. And I tell my students all the time that I'm a nerd and I'm a geek, and, you know, they laugh, they kind of chuckle at first. But, you know, if you kind of display that infectious enthusiasm for what you're learning, it's going to translate to your students as well. You don't need glasses to be a nerd. All right, the next thing I want to share with you about doing a culture of inquiry is using this instructional approach called the 5E method. So I'm sure some of you all are familiar with this, but basically it's an instructional model to really encourage inquiry. So we'll talk about this a little bit more in detail, but it's essentially, 5 E's: engage, explore, explain, elaborate, and evaluate. And I really want to stress here that though this is a lesson planning method, you really want to think about these verbs as being things that students do. You don't have to carry the weight of all these actions, and in fact, it's better if you don't. You really want students to be the ones doing these things. So the first part, engage, you know, it's for students to stimulate their scientific curiosity. So a lot of the suggestions I've seen come on the chat box here are about asking questions, having students be the one to lead the inquiry. And that's really essential. That's so much more engaging for them when they're examining something that they're actually curious about. The next one is to explore. So another thing that we've all mentioned in the chat box here, or many have, about doing hands-on activities and questions. Explaining is looking at how it applies to real-world situations and is supported by evidence. So that's a great way to draw in your text, you know, just and reading skills here for students to read about the concepts that you are exploring and discovering, and you know, see what's supported by the evidence. Does what they found in their experiment actually match up with scientific theory or investigation, or you know, is there a discrepancy there? Elaborating is to you know, see how it can be applied in different contexts or situations, and that's another really great, you know, opportunity to build it, make those real world connections. And the final one is evaluating by providing some time for review and reflection. And I'm going to sort of take you through a method of doing experiments that I think really incorporates all these facets. Okay, but again, I really want to stress that these are verbs, that it's not necessarily teacher actions. These are really things for students to do. So even explain, I think, you know, a lot of times as teachers, we're like, that's my role. I'm in charge of explaining. But it's really best if your students can be the ones to do that. You know, maybe you're providing them with the material and the evidence, but if they can be the ones to really, you know, apply those close reading strategies, see, you know, how the things are applied, and then explain it to each other, that's going to be even more powerful. All right, so, you know, one thing that's really necessary for students is, you know, for them to be able to do many of these skills, they need the vocabulary to talk about it. So we spoke about this a lot last week with math, but really the vocabulary for them to focus on are those high utility academic vocabulary words, and also the domain specific academic vocabulary. So I want to share with you just some essential vocabulary that they need for the science tests. And I'm sure these are terms, you know, that you're familiar with, and hopefully you're already teaching them. But these are sort of the terms that if students really need to know them. A lot of the science terms they can figure out from context, but these are ones that they really need to know, you know, just off the bat. So the first is hypothesis. Then we have variable, dependent variable, independent variable, of course, and also control. So I would love to, if you would be able to share in the chat box some different strategies that you use to teach vocabulary in your classroom. So we talked about some last week. If you want to share those, be happy to hear them again. But I'd love if you could share some other techniques that you use in your classroom. You know, not just for science vocabulary, but vocabulary in general. All right, heads up, cool. So that's a game we talked about last week, where you can put a term on a student's forehead, and they have to ask questions of other students to get clues as to what that, you know, what the term that they have is. All right, let's see, through pictures or examples, great, from Rosemarie. Teresa said, I use a PowerPoint with a slide for each word that includes a definition and a visual. Awesome. Yeah, visuals are so key. Okay, Whitney has suggested matching, that's great. Oh, Quizlets, those are so fun. Yes, Viviana, thanks for suggesting that. And great thing about Quizlet is that there are so many that are already created. You really don't have to do any work. You can almost just always find what you need. Or of course you can customize it. Diane has suggested related words. Arlene has said a KWL chart, that's great. Okay, Pamela has said give them the word, ask them what it means, give examples, great, real life examples, awesome. Sherry has suggested vocabulary on paper strips in a pile and having students take turns using them in a meaningful sentence, points to the team that gets the most right. Elizabeth suggested introducing words that mean the same, great. I observed a class last week with where a teacher had students bid on, she was doing it with grammar, this was Miss Margaret, I'll give her a shout out, but I think that could easily be adapted to vocabulary. Basically it was like students had to bid on how confident they were that they, you know, knew if the sentence was correct or incorrect, but I think you could do that with grammar as well. And of course, students always love when you give them fake money. So that's a great fun activity to incorporate. Okay, and finally, Cheryl has shared word families. Oh, that's great, to get more mileage from a base term. Awesome. Okay, so I know that Linda, when she does her presentation next week on reading strategies, is going to talk about vocabulary as well. So, you know, I think a big thing that our students lack is just really having the language to talk about, you know, what their thoughts are, or the scientific language or the math language or whatever it is. So really one of the best things we can do for them is to help them develop that vocabulary. So that's, again, a thing to think about, you know, across our content areas. All right, so what we're going to look at now, you know, now that we've talked about a couple ways that students can, you know, talk about the scientific method, we're actually going to sort of look through and kind of do it together. So the first step, you know, scientific method is great for a culture of inquiry because it starts with a question. All right, then you move to doing background research. So, you know, as I mentioned, that's a great place to tie in your reading skills. And then you want to have students construct a hypothesis, test it out with the experiment. And I really love this particular scientific method graphic because it gives you an opportunity to think, is your procedure working, yes or no? Because I know I've definitely experienced this with students. You know, you have your lovely set of instructions, but something can go wrong. You know, that not only mirrors the scientific method, but it's real life too. You know, sometimes you have a plan, but you have to adjust it. All right, and then of course, after you've done your experiment, you've gone through your procedure, you really want to analyze data and draw conclusions. And again, this is a great graphic, I think, because it shows you that your hypothesis isn't always going to be right. You know, sometimes you're going to think something and your experiment's not going to show that that's the case. So this really kind of takes you back to think, okay, what do I have to adjust in my experiment, and kind of go through the process again. And then last step, of course, is communicating the results. So that's a great place to draw in the writing skills that our students really need to practice every day as well. All right. So one really great framework for you know, teaching students how to create a hypothesis is this if, then, because model. So I know a lot of times with you know, creating a hypothesis, you'll see this if and then model. And that's great, but it really doesn't encourage, or I'll even say force here, students to think about the scientific reasoning behind what their hypothesis is. So this model, you know, the if is kind of like your experiment. Then is what you think is going to happen, and because is the reason why. So it's really great if in the because section you can encourage students to use that scientific vocabulary. So I've noticed with my students, a lot of them are really great if and then it's like no problem, they can get that down. But the because part, where they actually have to think, okay, what evidence do I have that supports why I think this, can be challenging. But it's a really good framework to have them try out. So we're going to try that in a little bit, but I wanted to show you an example first. So I know this is kind of a wonky picture here, but this is actually from an experiment that I did with my class about a year ago now, and the hypotheses that they came up with. So you can see that I sort of gave them the framework there, but I had students come up and actually fill in, you know, the other parts of the framework. So this was about, you know, osmosis and different types of solution. Basically, we used a potato, because that's what I had in my refrigerator, and we put it in a concentration of salt water, and then, you know, had it in there for a certain amount of time, and then we, you know, measured if it gained or lost mass. And this was really great because, you know, we integrated math skills there. We did the percent change, which was, you know, a math skill they didn't really have to begin with, but we learned it through this activity. And I will say, you know, if you notice on our data chart here that our results didn't necessarily align with actual scientific fact, but that's okay. You know, that's part of the process. And like I said earlier about celebrating mistakes, you know, sometimes you do an experiment and that's what happens. And that's, you know, a really great opportunity to have a discussion about, you know, what happened in this experiment that maybe caused our results to be skewed, or, you know, should we try it again? And I know in this example, some students had put their potato on a paper towel, which had absorbed some of the water first before they measured it. You know, so it was great for us to kind of go through and have that discussion about, you know, what things happened in the experiment that might have affected our results. Really like real scientists do. All right, so we're going to have a chance now to actually come up with a hypothesis. and work in breakout groups to come up with an experiment. So if you, let's see, I'm going to send out now via our chat box the link to the Google Doc. So if you can take a moment now, just while I'm talking through the next couple slides, to access that Google Doc, it's in the chat box. Because when we go into breakout groups, I don't believe you're going to be able to see the slide and the next couple ones of directions. Okay, but basically what you see on the slide now are Newton's laws of motion. So I chose this particular scientific concept for us to do an example of today, because this is a really great concept to discuss and explore with students, particularly if you're preparing them for the GED science exam, because you can pull in a lot of math skills. And it really does a great job of addressing that high impact indicator of applying scientific formulas, just sort of naturally given the content. All right, so you'll have this on your Google Doc to see. Okay, oh, so I have a quick question here from Whitney. Said, are they putting this part back on the test where students have to create an experiment? I'm so glad you brought that up, Whitney, because the writing portion of the GED science test has been removed. You know, as of last year, they said it's definitely been removed for 2019. They haven't given a firm answer of whether or not that writing will come back. But as you know, for the rest of this year, it won't be on there. And you know, the science test, the length of it has not changed, but essentially they're assessing that competency through other test items. So even though you know, students don't have to create an experiment and write about it, this content is covered majorly on the test. So you know, doing these activities is really great for helping them prepare, you know, even just for those multiple choice or the drag and drop items that they're assessed with. All right, so what we're going to do next is go into our breakout rooms. So if you were with us last week, want to give a couple of little pointers before we do this. So essentially what's going to happen is that we have 28 participants on the call today. We're going to get split up into groups. I think I'll do 4 groups. So basically you will have the opportunity to talk in your breakout room. So, and I'm going to give you a little assignment, which I'll talk about in a minute. And we're going to take 10 minutes to do that. And you will get a 30-second warning before the room closes, and you'll just automatically be brought back to the main presentation. I can pop in on any room, so I'll try and do that so I can visit and see how everybody's doing. And just a key point here is that if you haven't pulled up that Google Doc yet, you definitely want to do that now. It's still visible in the chat box so that you have the materials for what we're working on. Also, if you're calling in via phone today, sometimes it can be, I think there might be some difficulties in joining a breakout room, but great news is that we can kind of have a separate breakout room within the main discussion now. So if you're not able to join one, just stay where you are and we'll work as a group in the main room. All right, so what are we going to do in this breakout room? Basically, what I'd like you to do is use the if, then, because template or framework to formulate a hypothesis about one of Newton's laws of motion. Then you're going to design an experiment to test the hypothesis using only objects that are currently in the room with you. So that's the tricky part. So I see Gina looking around. She's got a computer lab. So the note with that is that if one person, at BCCC, for example, if you have a ruler and somebody else at Prince George's has, some other object that you want to use, you can combine objects. But this is just to kind of get you thinking about how can you work with what you have. All right, and what I'd like you to do is designate one member of your breakout room to describe the experiment in the chat box. So after you've had some time to discuss it, pick one person that's then going to share your results with our entire group. All right, so we're going to do that now. So you should see a little pop-up panel in a moment. I popped in on all the rooms and most of them I heard good conversation. It looks like most people were able to communicate in some way, even if you didn't have microphones. So I appreciate you making it work. I heard somebody talking about a cat, what they could do with a cat. That seemed very intriguing, but I didn't want to stay too long. But I would love if you were able to, kind of share your experiments in the chat box. As I said, I heard some really good ones. So if you could share, what you have, that would be great. And are you able to, y'all are able to see my screen right now? No? Okay. All right. Let me Okay. Can everybody see now?
Yep, you just have to do the share.
Okay. All right. So if you, let's see if we have anything in the chat box of ideas here. If I can get it to come up.
So I don't know if you can see, because our group was sharing and it might just be in my group. Linda Hall shared that Minnesota Literacies has a nice reading activity that has to do with LeBron James and Newton. So
oh, nice.
I will copy and paste it for everyone to see here.
Great. Okay. All right. So I will go ahead and share with you the experiment that I've done with my class in regards to this, but I hope that you'll continue, putting in what you came up with in the chat box. So something I've done with my class is just to experiment how the angle of an inclined plane affects the acceleration of a ball traveling down the inclined plane. And that sounds pretty fancy. We're using good vocabulary there. But basically, we made inclined planes just out of some rulers that we happen to have in the classroom, and then just stacking up some textbooks. You can kind of get more specific with this if you want. If you have protractors, you can actually measure the, the different angles that you have. But it also works to just do like low, medium, and high. And then we just used, the timers that students had on their phones, tape measures, and then what we did was we used a plastic cup to actually, capture the ball, as it rolled down the plane. Obviously there's a lot of factors that are open, that are not consistent among here. We're not exactly following a great scientific method because we did sort of have more than one independent variable. But the students did do their best just to kind of, hold the ball and just let it go naturally at the top of the plane, not really putting any force behind it. So that's one thing that you can do just from materials that are right there. But whatever experiment you do, it's really important to follow, to have a procedure. So a great thing to do is if you have students actually coming up with the experiment, see if they can actually write down the instructions. And sometimes what I've done is, have put students in groups and have different ones come up with instructions and see, can you write a procedure that's clear enough that someone else can follow it? Because a lot of times when you design something and you go to write instructions, you know what to do because you put it together. But it's a great test, for students to see, is their writing clear and are they really including all the relevant details, if they're able to write those directions for someone else. Another thing that's important to emphasize is, not just doing the experiment one time, but doing it repeated times. And always a great, very simple thing to draw in when you're doing experiments is to calculate averages. And we know that measures of central tendency are a big part on both the social studies and science exams, and also assessed on math just to a degree as well. So that's something I almost always have students do is, if we did an experiment in groups, what's the average of what everyone got together? Is it consistent, or is there somebody that's way off? What is our range? But anytime you're doing an experiment, measures of central tendency are a great thing to draw in. Also, of course, you want to have a place where you're going to capture your data. So, just kind of modeling or encouraging students to develop some kind of table where they can capture what they are testing. So in mine here, you have the length of the inclined plane, the angle, the distance from the edge of the plane, the time it took for the ball to reach the cup. But all, you can kind of customize it for whatever. And what's kind of great about this experiment is that, it can, and I heard somebody mention in one of the breakout rooms that, a lot of these can test more than one law, and that's great. You don't necessarily have to just look at, the first law or the second law and kind of look at that in isolation. You can examine all those laws of motion together. And the final thing you want to think about, or I wouldn't say final, but another important thing to think about with teaching the scientific method is that you always want to have students create a chart or a graph to express their findings visually. I find with students that this is really, really challenging, and it often takes longer than I think it will, but it's really valuable for them. And it's also really rewarding. I know a lot of my students, they're like, oh, graphs, I hate them, charts, I hate them, I don't know what to do. We'll talk a little bit later about a really just quick, easy strategy to teach students with, sort of how to approach charts and graphs. But if you take the time to actually have them build a chart or a graph, it's going to have great impact for them. that really requires them to delve deeply into what they found. And it's always interesting, a lot of our students, like, first instinct is a bar graph, but it's really great to have the discussion of, okay, well, what's your data and what's the best way to display it visually? A bar graph might be what's easiest for you to make, but for somebody looking at it, are they really going to understand, the conclusion that you drew, or sort of the main point of your experience from looking at it? Or, would another mode be best to display that? All right, so we're just kind of coming back to the scientific method here. But again, it's really, we're just sort of focusing on that, analyzing data and drawing conclusions. And as an essential part of that, really, I always like to have my students make that graph before they really draw a conclusion. It's hard to get them to do that. And of course, they're gonna have ideas based on just what happened from the experiment. But really, that's a great thing to do to sort of communicate that idea that sometimes doing a graph can reveal new things. And it can, show you a concept in a way you hadn't thought of before. Many of our students, they don't connect with that immediately because they haven't made a chart or a graph before. But I know, as I said, this is a really challenging activity, but it's one that my students always take a great deal of pride in. It's something that, like, they're snapping pictures of their cell phone, like, oh, look at this graph I made, because they want to show somebody else. So I really encourage you to do that with your students. All right, so before we switch over, we're gonna do a little bit more science, but I would love if you could kind of think about some connections you can make to science content, math connections in particular, excuse me, to maximize your instructional time. So I just kind of shared with you the idea of averages or graphs, but I'd love to hear what other ones you've either done or you could see doing, some ideas that you have there. All right, I know there's math connections out there. Averages, great. See how fast something moves, awesome. Okay, rates of speed by weight. One-step equations, yes, for sure. Okay, now they're coming in. All right, talking about right triangles when analyzing planes, for sure. Diana has said, when students come up with ways to solve math problems, have them test to see if the strategy will work in other situations. Yes, strategies are great. Whitney suggested distributive property with chemical equations, great. Well, percentages and measurements, for sure. Slope, oh, I hadn't really thought about them, that's great. Teresa said if we're talking about a ball in an incline, we could calculate how changes in slope affect velocity. Great. Slope's also a great thing if you're having students make a graph. If it's a line graph or something like that, have them calculate the slope too. Okay, formula for acceleration, how to apply the results and set up your graphing from Arlene. Whitney has set a coordinate plane, independent, dependent X and Y connection. That's so amazing. I hadn't thought of that, Whitney. Thank you so much. I love that one. I'm going to try that for sure. Yeah, great. So please keep them coming. Those are awesome. And as we said when we started today, really want to focus on strategies and things you can do that connect content. We know we have limited time with our students, so anytime you can pull math in, the better. We know from what Adora presented that that's the section that our students are struggling with the most, is that math exam. So the more we can do to prepare them for that test, the better we're going to serve them. All right, so I just want to really briefly share with you some low prep and low cost experiments. I'm going to go through these quickly because I want to stop time for social studies. But I'll share before we get into these that I have materials, reading materials and questions and activities for all of these experiments. So feel free to email me and I'm happy to share them with you. They're all just Google Docs. All right, so the first one here is about basically testing the rate of dissolution. You could do this with any candy, just seeing how fast it dissolves in water and how temperature might affect that. And all these experiments that I'm sharing now are ones that you could do for like $3 or less. And you can always crowdsource the materials. So you might have one student bring in a pack of Skittles, and someone else is in charge of bringing in the thermometer. If you don't have these materials, figure out who in your class does and kind of collaborate and bring them together. Another one is cleaning pennies using salt, water, and vinegar, trying to figure out which one is most effective. Again, simple, easy stuff. Even though I know I don't carry cash around, so actually finding the pennies would probably be the most tricky part. Another one is, this is the one I shared with you with the sample hypotheses that my students had done. Trying to figure out the concentration of a solute in a solution, how does that affect the rate of osmosis? You can really do that with sugar, salt, water, and any kind of vegetable or fruit. And it's kind of interesting, that's a great way to make connections to cell membranes. So there's lots of things you can draw in here. Strawberry DNA extraction is pretty fun. I've done this with my class, and I was really surprised to find out that strawberries have haploid DNA. So they have 8 times the amount of DNA as a person does. So that's why it's really easy to extract DNA from a strawberry, because you can actually see it. So you see in that photo there on the little popsicle stick, that's actually the strawberry's DNA. So that can be more of a demonstration experiment, but you can also have students hypothesize about, what do they have to put in that extraction buffer? What ratios and proportions of things are going to work best to actually get the most DNA out of the strawberry. And then that's a really great connection to all the genetic concepts that are on the exam. You almost always get a Punnett square, so it's a great way to sort of pull in and introduce students to that concept.
So Vicky asked a really great question in the chat box, Kathleen.
I lost my chat box. Could you read it?
That's okay. She says, where can we find questions like the GED Ready? There are so many concepts that are not in the book sometimes, like cladograms and carrying capacity in science and opportunity costs in social studies.
Yeah, so Whitney, I'm glad you asked. In about, I think, 3 or 4 slides, we're going to look at a bunch of different resources for science. So I have a bunch of links to share with you of good science resources. So I'll just share quickly here. This is another fun experiment with vinegar and baking soda. I know when I actually decide to clean my bathtub very rarely, I really like doing vinegar and baking soda. It's a nice sort of environmentally friendly cleaning product, but you can also use it for a science experiment. So the one you see here is sort of using a balloon to capture the gas that is let off when you combine those 2 things. So that's a great way to introduce students to the concept of balancing equations. I think someone in the chat box had mentioned that earlier too. Okay, so before we transition, wanted to just take a brief moment to look at a couple examples from the science item samplers. So just wanted to show you these. I'm sure you're familiar with them if you've used that with your class before. But basically just to show you that, the activities that we've described here, they're sort of hands-on ways of getting students familiar with this content. You can see a lot of it here. It's about the vocabulary. Do they know what the question is asking? And if you've done experiments, can they apply that scientific method process to, things that they're going to encounter on the exam? All right, so now resources. And if you have the Google Doc with that you use for the breakout rooms, I've linked all these there for you. So the first is the National Science Teachers Association. They have a lot of really great freebies for teachers. Mythbusters is a fun TV show, and I believe you can access all the episodes on Discovery. There's study jams. I haven't done too much with that one. That's one that the GED testing service has recommended, but I'm sure if they've said it's good, there's some good stuff there. We also have Noon's Apple. That's another video segment show. There's Steve Spangler. He does a lot of really good, like low-cost, low-prep experiments as well, kind of like everyday kitchen science. So they're pretty accessible. There's TED Ed, and then of course Khan Academy. And another one that GED Testing Service has highlighted is Science with Mr. Jones. There's tons of stuff online, of science teachers who have materials that they just share with everybody. And I'll say again too that if you're interested in any of those experiments, I'm happy to share the materials with you. You can just send me an email and I'll give you access to the Google Doc. All right, so we have slightly under half an hour left to talk about social studies, but I sort of intentionally planned it this way because a lot of what we've talked about, and also a lot of what Linda will talk about next week, I'm sorry, are strategies that you can use on the social studies exam. So briefly start off with a poll here. Would love to know of these skills, what you feel like your students are comfortable doing. Okay. All right, so if you can mark all that apply. Okay. And Gina, I'm not seeing the poll results, so if you could just share them when we have a good percentage of people voted, that would be great. Okay. All right. So looks like a lot of students are comfortable with interpreting maps. I hope they come teach mine because it's something we struggle with. Have about a little less than 20% are able to find measures of central tendency. I'm really happy to see 56% can draw inferences from a text, and also 69% correctly sequence major historical events. So that's really exciting. We're going to talk about a couple strategies to address, all of these skills with the rest of the presentation. All right. Okay, so like we saw with science, GED Testing Service has put together sort of this handy little guide for basically, the content you should teach to prepare students for the social studies exam. So I realized today as I was preparing for this presentation that there is a mathematical error. So whoever can find it first, you get a virtual high five. You just type in the chat box if you see where it is. But as you're looking for that, essentially the major bulk of the test is on civics and government. The types of modern historical governments, the structure and design of the US government, political parties, contemporary public policy. So I know a lot of my students are like, I don't know, when this war was, or, who was president at this time. And they have a lot of anxiety about that, but that's not very necessary for them to know on the test. There's only 20% US history even assessed, and most of that is, reading passages they make inferences from. So I always work with students on building that background knowledge, but I really stress to them that it's the most effective skill for us to work on is close reading. So we're going to talk about that today. But the more background knowledge, the better capacity they have to understand what they're reading. So it's sort of a twofold approach, but you can sort of relieve some anxiety in that way. So has anybody been able to spot that mathematical error? Okay. No. All right. These percentages add up to more than 100%. So I noticed that just earlier today. But the main thing to remember here is that civics and government is the bulk of the test. All right, so we'll just look at this quickly here. As we talked about with science, there's the content to cover, but more important are the skills to really delve into. So you see a lot here about analyzing, drawing conclusions, interpreting graphics, charts. And again, like we've seen, across our content areas, there's a lot here that doesn't just apply in a social studies context, but also applies in math, science, and reading as well. So this would be a good one, if you want to come back and kind of examine this a little bit more when you get the presentation to kind of really zero in on the skills here. But the main things are, drawing conclusions, making inferences, analyzing, critiquing, and interpreting. All right, and again, here we have our high impact indicators for social studies. You take a couple seconds here to sort of read through them. But these high impact indicators are really, if you can focus on these, you're going to have successful students. And these are great because they don't just impact the one subject area, they really go across content areas. Okay, and the one that I really love to do with students is the final one, where you see compare treatments of the same social studies topic and various primary and secondary sources, noting discrepancies between and among sources. I don't know if you've had this experience, but I find that my students really love when they find something printed that's wrong. Initially, it's really like off-putting for them. They're so hesitant to say that it's incorrect. but once they do, they love being critics. So, you know, kind of showing them like, here are two sources, and what do you see? You know, why did one source say it this way, and why did another person say it this way? Is really, it's pretty fun. And I think it's fun, you know, for us as teachers as well. And of course, it's always a joy to see when students are enjoying an activity. All right, so I wanted to just briefly talk about some strategies for building visual literacy. This is the main one that I use with my students, and it's really, really simple. But it's just, you know, a quick little acronym here called TALK. So each letter, you know, as you can see, stands for something. So T is title, A is, we say all the way around or look at the axes, L is look and label, and K is for the key. This is like pretty much the one and only main strategy I teach students when we're looking at charts and graphs. It's very simple, but it really has a big impact. I know that a lot of times my students, you know, just the fact that it's a chart or a graph means they're intimidated by it. They're scared. They don't even like want to attempt to interpret it. So just kind of zeroing their attention into something as simple as looking at the title. It's so basic, but it gives them a place to start and to kind of relieve that anxiety. Another major thing is just looking at all the text that's there. I find a lot of times, you know, they don't look at what's on the side. So of course they can't understand what's going on. So really just kind of going through this simple strategy encourages students to read everything that's there. And if they have all the information, they're so much better equipped to actually draw an inference from it. I also really like encouraging them to label things that aren't labeled. You've probably experienced this as well, where you have students, you know, they're looking at a graph and it goes from 0 to 5, and you know, the bar is in between there, and they're totally lost as to, you know, well, it's not at 5 and it's not at 0. How do I figure out what this number is? So I like to encourage them to, you know, label what's not labeled. You know, what inferences can you draw and just add in for yourself to help you understand it better. And of course, the key, again, very basic stuff that, you know, we sort of take for granted, but sometimes our students don't know to do these things. Okay, and also I was happy to see that a lot of folks feel like their students are great with maps. Just a very basic thing that I've found is that sometimes students don't know the cardinal directions. You know, they don't know what a compass rose and what those letters stand for. So some little mnemonics to teach that are never eat shredded wheat. I learned that from my 4th grade classmate, Mary Beath. I still remember when she said that in class. And then I recently found out another one, never eat soggy waffles. And then, you know, another major thing I found that students often need help with is just understanding the scale of a map. You know, so what does an inch represent? What does, you know, a centimeter, or whatever scale it's in? And that's another great math connection that you can draw, and just kind of, you know, saying what's the distance between these two places, and kind of figuring out based on the scale. All right, so major thing I want to communicate here is just connect to math whenever you can. We've talked about that a lot with science, but it's possible to do in social studies too. So more connections you can make, the better. Try and, you know, even if it's social studies, try and do it every day. Even if it's science, we've seen a lot of places you can connect there. But that's the test our students struggle with the most. So, you know, even if you're teaching a reading class, think of yourself as a math teacher, because that's really, you know, we have to help our students in all these competencies. All right, one thing I want to briefly touch on here is this concept from GED testing service of enduring issues. This is a little less important now that they've removed the writing portion from the social studies test, but it's still something you can see, you know, across the test as a whole. So basically, these are just issues that they, you know, say many societies face and have attempted to address with varying degrees of success. You know, things like an individual's rights versus the common good. You see a lot of civil rights text and, you know, bills and things on the test. So that's a major area to cover. Separation of powers, checks and balances, states' rights versus federal power. You know, there's kind of some trends that you see on the test. There's a lot of stuff about the United States relationship with Russia, or, you know, as I mentioned, civil rights. So those are kind of common things that you often see pop up. Okay, so we'll look quickly. You're probably familiar with this, but this is just an excerpt from the test itself, showing you a sample question. This is just from the item sampler, excuse me. So why don't you just see if you would share in the chat box of what you think the skills are that a student would need to be able to answer this question. All right, I'm not able to see the chat box at the moment, so I'm going to see if I can pull that up. I'm going to stop sharing for just a minute because I want to be able to see what you all are sharing with us. All right, so, oh, great. So Whitney, you noticed that the economics is 15%. Thank you so much. And you said you use TAILS. If you want to share with us what that acronym stands for, I would love to hear. But Jamie has said vocabulary for the question we're looking at now. Any other ideas of what a student would need to know to be able to answer this? Or kind of the skills they would need to have? Okay, yeah, what branches of government can do what? That's major. Yep. Okay, powers given to the president by the Constitution. Mm-hmm. Pamela, thank you. All right, thanks Whitney for saying what TAILS means. That's great. I love the intervals connection there. I'm going to use that one. Okay, Patricia has said background knowledge on the 3 branches of government. Great. So you can see, you know, a big thing on the test here is that there's a lot of stuff that you can figure out from what's there, but the more background knowledge you have, the better. So that slide a few back where we saw sort of the main you know, units of study that the GED testing service recommends, those are really good ones to use to structure your, you know, what you do in your units and what you teach your class. Okay, and Rosemary has said the student would have to know the powers of the executive branch. Great. Yep. Okay, so, you know, as we see from the test, most of it is primary sources and historical documents. So, you know, why do we use those in class? It's great because it puts students in the seat of acting like a historian. You know, just like we want them to do science, it's the same thing when we're studying social studies. Historians a lot of times study documents. So having students do this really prepares them, you know, not only for the test, but also, you know, for really what that profession is like. It prompts historical inquiry, which is major. Makes students connect the past to the present. That's a great thing to do in social studies, and especially with, you know, branches of government and our laws. That's so closely tied to current events that it can be really engaging for students. It can also, you know, cause some intense discussions. You have to navigate that as best you can. That doesn't mean you should stay away from it. It definitely encourages higher order thinking and also teaches multiple perspectives of history. And so that's something I really want to stress is that, you know, the GED exam, I'm a little nervous to say this, I don't know who's listening, but it does have, you know, there's a cultural bias there. But just because of that doesn't mean that you can't teach students, you know, other parts of history. So you really want to teach students what's going to be interesting to them. But just to kind of talk about a quick process for primary source documents is, you know, select one, research the historical context of it, select a strategy for close reading. We're going to talk about one in just a minute, and then create your lesson around that. But again, you know, as I mentioned earlier with science, you know, a lot of times these are verbs that we think a teacher has to do, but students can just as easily do these. You know, you're going to have to give them some guidance of selecting that document, but why can't they be the ones to do the research? Maybe you teach them a close reading strategy and they're the ones to select which one to apply. And I've had students, it's been challenging, but again, you know, the challenging lessons are where they really learn the most. You know, we'll kind of, like we did it with Supreme Court cases. So everyone got assigned a case, they had to do research about it, make a presentation to the class, and they also had to find a primary source connected to that case and create questions about it. It was really, really challenging for them, but they did a great job with it. And, you know, working in pairs kind of helped us out there. Okay, so we got a quick poll here. Okay, so this is just a would you rather question. All right, we'll take a few more seconds. All right, I'm going to share results now. So I'm kind of surprised by these. I thought everyone would choose none of the above, but it looks like a lot of people would enjoy, you'd rather have students read an excerpt of Federalist 51. So cool. I have to say that reading that doesn't really excite me, but I'm glad that you all are so scholarly that sounds interesting. But basically with that, I sort of wanted to make the point, I don't know if it's relevant here, but cater to your students' interests. So if that's something that's going to interest your students, by all means go for it. If not, try and figure out what's going to interest them and do deep study of that. And again, we've seen what the main material of the test is, but that doesn't necessarily mean that's what you have to examine closely if that's not what's going to really interest your students. Okay, and Whitney, your students must be like mine. You're saying it won't, not my students. So we'll see. But what we're going to take just like 2 minutes to do here is I love if you have a piece of scrap paper, we're going to do an alphabet brainstorm. So what you need to do is down the side of your paper, you're going to just put the letters of the alphabet, A through Z. And I'm going to give us 90 seconds now. Actually, we're going to cut a little bit short. I want you to see how many primary sources you could come up with that align with each letter. All right, and I'll admit that I tried this yesterday. I timed myself. I gave myself 2.5 minutes. I got maybe like half the alphabet, but just see what you can come up with now. So I'm trying to get my timer going. We will go ahead and begin.
Kathleen, can you repeat what the topic is?
Yes, so you want to see if you can come up with a primary source that aligns with each of those letters. All right, so take 30 more seconds. All right, so our timer's up. Hopefully you were able to at least get a couple there. But I just wanted to share that strategy really to get us thinking about, what beyond sort of the foundational American documents like the Declaration of Independence and the Bill of Rights, what are some other ones that you could see using with your students? And I love, if you want to throw some ideas in the chat box, that would be great. I'd really love to get a couple suggestions. But, those foundational documents are great, and I think, they're a wonderful starting place. I almost always do the Bill of Rights with my students because that's really interesting to them. But you want to find out what's something that they're interested in that they really want to study deeply. Because the idea with these primary source documents is not that you want to read it one time, do a couple multiple choice questions, and turn the page and move on to the next one. What do you really want to study, for an entire class or a couple of classes that's going to really interest students? And as I mentioned with science, sometimes it's hard to get students thinking in that way of like, I actually have power in this class to decide what we're going to learn about. But you can get there. So, if you give them suggestions or you have an array of choices for them, those are really great things to do. So I love, Diane, your suggestion of executive orders. Karen's got the Gettysburg Address, Emancipation Proclamation. I saw somebody else, I'm not sure of the name, but I saw earlier Ship Manifest. Those are all really interesting things. And again, we know that what you're excited about, you can get students excited about, but we want to, incorporate their interests as much as possible. And thanks, Verona, for the time check. I know it's almost 3. We got just a few more things to look at. Oh, Declaration of Sentiments, Whitney, is a great one. Okay, so just very briefly, we're going to look at a strategy to actually analyze primary sources. I'm not going to go too deeply into this because I know Linda is going to do a lot of this next week. But this is an analysis tool from the Library of Congress, where basically a three-part process where you observe, reflect, and question. So first thing, just with observing, is what do you notice? What's unfamiliar? How's the information arranged? Just kind of basic stuff about the text. Second is to actually reflect. What's the purpose of the document? Who is the audience? Who is it written for? And I really love this question they have here, is what events were happening around the creation of this document? What's the cultural context and the historical context of why it was written? All right, and then the final one is to question. Again, we're going back to that culture of inquiry. So, this idea that as a reader, you can actually, the author's not the authority, you can critique them. What claims do they make? What evidence do they have to support it? What else do you wonder? If we think about that high impact indicator, does it line up with what other documents around the same time said, or does it make a different claim? Why? Just constantly asking why. All right, real quick, and again, these are on the document that you did in your breakout rooms, but there are some really great resources out there. You don't have to do this stuff from scratch. There's tons that is already made. So Library of Congress has a really great primary source analysis tool and a ton of lesson plans that are already put together for you. It's kind of just print and go. There's really great primary teaching source sets at these two sites here. I'm going to kind of go through these real quick. There's DocsTeach is another great site where there's activities that go with the primary source documents. Annenberg Classroom is a good one. And then my personal favorite, which I really recommend for you, is Facing History. So this is a great resource for sort of looking at those parts of U.S. history that maybe we wish, didn't happen, or that are sort of embarrassing, and, that we regret as a nation, and kind of looking at them and examining, what went wrong, how did those choices impact people, what are the impacts of them today. So this is a great one to use to kind of, examine history that's not necessarily in the history books. All right, the last thing I want to leave you with today is just kind of linking back to that culture of inquiry, and just this idea that learners should question answers just as often as they answer questions. And maybe even they should question answers more than they answer questions. So this is the idea that, as facilitators in our classrooms, we're not the ones with all the knowledge. We really want students to be the ones that are driving our instruction. So I hope you'll think about that today. I know that's something that I always kind of keep top of mind, and it really makes sure that students are at the center of what we do. All right, so thank you so much. If you have any questions, you can feel free to email me. If you want any of the science resources that I shared with you, I'm happy to pass them along. So thanks so much for your participation and your willingness to try something new today. And I'm really excited, as I was last week, to go back through the chat box and see what ideas I can steal from you. Thanks so much for the opportunity to chat with you today. Hope you have a nice rest of your afternoon.
Thank you, Kathleen. And if anyone needs anything, I will be sending out the email with the proof of participation, a copy of the presentation, a copy of the recording, just like I have for the last few sessions. But agreed with Kathleen's sentiments. Have a wonderful afternoon.